when factoring trinomials, we're going to need to analyze a product of two terms and the sum of two terms. So in looking at this, the product that we're going to take is this coefficient, which in this case is 1, times the constant of 30. So we're really looking at 1 times 30, or 30, as a product. And the sum would be this coefficient here, 11. So what we're really looking for is two numbers that multiply to 30 and add to 11. So first, we can just list the numbers that multiply to 30, and you might first think 10 times 3. But when you add 10 times 3, when you add 10 plus 3, you get a sum of 13, which is not 11, so I'm crossing that out. Next, we can look at 6 times 5. Well, 6 times 5 equals 30, and 6 plus 5 equals 11, so I know that 6 and 5 are the two numbers that both multiply to 30 and add to 11. So this looks like it's a bit of a shortcut, but we're going to have two groups of factors, each starting with x, and we're going to have a positive 6 and a positive 5. When you FOIL this arrangement, you will have x times x, which is x squared, x times 5, which is plus 5x, positive 6 times x, which is plus 6x, and positive 6 times positive 5, which is positive 30. When we combine the like terms, we will arrive at x squared plus 11x plus 30, which was our original polynomial, so we know we have factored it correctly. Many students will have learned a shortcut to do this, but using this method will help you later on when this coefficient is no longer 1. So to abbreviate, I will make a product sum chart just by writing the letters P and S. My product is always going to be this coefficient times this term. So this is really 1 times 10, which equals 10. The sum is always going to be the middle term, keeping in mind that it does have a sign with it. So my sum is going to be positive 7. Since all the numbers here are positive, I don't really need to worry about negatives just yet. So if I wanted to look at two numbers that multiply to 10, I could take 1 and 10, but they add up to 11, so that's not going to be the correct combination. I could also take 5 times 2, which multiplies to 10, and that adds to 7, so I know that I have the right combination. I'm going to use the structure here of having two binomials that multiply together to equal this trinomial. Since my first term is y squared, I know that each binomial starts with the variable y. Now I'll look at the signs of these two numbers. I have positive 5 and positive 2. Next, you can FOIL this just to double check that this structure works. Y times y is y squared. Y times positive 2 is positive 2y. Positive 5 times y is positive 5y. Positive 5 times positive 2 is positive 10. When I combine the like terms in the middle, I will have y squared plus 7y plus 10, which is my original polynomial, so I know that I have factored it correctly.